Hello everyone and welcome back to I Am Technos. In this video, let's explore what fine-tuning is, why it matters, and a hands-on demo on how it works inside Amazon Bedrock. So let's start by understanding what a fine-tuning is. Fine-tuning is the process of taking a pre-trained foundation model like Amazon Titan or Anthropic Claude and training it further on your own dataset. This makes the model specialize in your domain instead of being broad and generic. Now, why choose fine-tuning? Foundation models are highly capable, but they may give generic answers. They may not use your company's terminology, and they may lack task-specific accuracy. Fine-tuning solves this by teaching the model your style and the exact way you want to respond. Of course, fine-tuning isn't always the right choice. It works best when you have a small but stable dataset, when the task is domain specific, and when consistency really matters. On the other hand, if your data is constantly changing, a retrieval approach works better. And if you only need general answers, a pre-trained model is often enough. So how does this actually play out in Amazon Bedrock? The flow is straightforward. Choose a foundation model, prepare your dataset as input-output pairs, and upload it to S3. From there, you create a fine-tuning job in Bedrock. The system trains and validates your model, then you deploy the fine-tuned version. Finally, you test it, refine it, and repeat if needed. Now let's walk through the hands-on process for creating a fine-tuned model. We start with the foundation model, which provides a strong base of general knowledge. Next, we fine-tune it with the dataset in S3, allowing the model to specialize in the domain and adopt specific terminology and style. This produces a custom model designed for the intended use case. Finally, we test and iterate as needed, evaluating outputs. In real time, we can refine the dataset to ensure consistent, reliable results. I'm in the AWS Management Console. Before we start fine-tuning our model, let's take a look at the dataset we will be using. Here is the example of one line from the dataset. First, we have system instruction. This is what sets the assistant's personality. Basically, it tells the AI how it should behave. Next, there is a user message. This is the question coming from the person using the AI. In real life, that could be an employee, a manager, or anyone chatting with the assistant. For example, the user might ask, what is our internal project code for the AWS migration? And finally, there is the assistant's message. This is the AI response, the part we are training it to say. For example, the project code is MIG 2025. So this format helps the model learn exactly how to respond to similar queries in the future. The dataset contains several project-related Q&A pairs. Each line in this file is one training example, such as the user might ask, what is the lead architect for the AWS networking setup? And the assistant would respond, the lead architect is John from the cloud team. Or the user could ask, what is the approval code for launching new EC2 instances in production? And the assistant answers, you must use approval code EC2 PRD 789 before launching. Like this, we have examples one by one. I'll share the documentation link in the description so you can explore a sample dataset and try it out yourself. Please note that this information is specific to a particular example project, not general AWS knowledge. So by fine-tuning the model on this dataset, we ensure the custom model has proper training and can provide accurate project-specific responses rather than generic answers. So save this file in JSONL format, as this is the supported format. Next, let's upload to S3. Open S3 from the AWS Management Console and click Create Bucket. Give the bucket a name, for example, fine-tune dataset 2025. Scroll to the bottom and click Create Bucket. Click on the bucket you just created. Then upload the dataset file by dragging and dropping it into the console. Scroll down and click Upload. Once the upload is completed, click Close. Your file is now uploaded and ready to use. Now in a new tab, search for Bedrock and select it. In the left navigation pane, under Tune section, select Custom Models. Click Create, then select Custom Model with Fine-Tuning option. Under the model details, give the job name as MIG25 job. Click Select Model. Choose Nova Micro. Then click Apply. For the model name, enter MIG25 model. Next step are the hyperparameters. These are the settings that control how the model learns. Let's start with epochs. This is basically how many times the model will go through the entire training dataset. The range is between 1 and 5. More epochs means more learning. But if you push it too high, the model can overfit. For tiny datasets, 2 or 3 is usually enough. So in this demo, I'll stick with 2. Next, let's talk about the batch size. When the model is learning from the dataset, it doesn't always look at the entire dataset at once. Instead, it breaks the data into smaller groups called batches. The batch size is simply the number of examples the model looks at before it updates itself. If you choose a smaller batch size, say 2 or 4, the model updates very frequently. This usually gives better accuracy, but training takes longer. If you choose larger batch size, like 32 or 64, the model processes more data at once and updates less often. This makes training faster, but it can sometimes miss smaller details. So batch size is really about balancing speed versus accuracy. For most use cases, starting somewhere in the middle, like 16 or 32, works well. Based on the model we selected, the batch size has set to 1 by default. Next is the learning rate. This is a setting that controls how quickly the model updates itself while training. If the learning rate is set too high, the model updates too aggressively. That makes training unstable and the model may never settle on good results. If the learning rate is set too low, the model updates only in tiny steps. It will eventually learn, but training will be very slow and might get stuck without improving much. The key is to pick a balanced value, not too high, not too low, so the model learns steadily and efficiently. Since my dataset is small, I'll stick with the default value here. Now that we understood the learning rate, now let's take a look at what learning rate warm-up steps mean. At the very beginning of the training, the model might not be stable if we throw the full learning rate at it immediately. Warm-up steps fix this by gradually increasing the learning rate from 0 to the target value, which is 0.00001 over a specific number of steps. For example, if I set warm-up steps to 10, then for the first 10 steps, the learning rate will start very small and increase linearly until it reaches 0.00001. After step 10, it stays steady at that learning rate. So this way, the model learns smoothly and avoids sudden shocks right at the start. Now, let's look at the input data section. Here, we need to specify where the training data is stored in S3. So click on Browse S3, select the bucket we created earlier, choose the dataset object, then click Choose. We also have Validation Dataset S3 location option. This is optional, so for now we will leave it blank. Next, in the output data section, Amazon Bedrock will save the validation results. I'm selecting the same bucket for output, but if you prefer, you can choose a different one. Again, just click Browse S3, pick the relevant bucket and click Choose. If your data is in private network, you can select a VPC to access S3 securely. Otherwise, just leave it as no VPC. Finally, Amazon Bedrock needs a role with permissions to read and write from S3. So select a Create New Role, give it a name, for example, Fine-Tune Role, and then click Create a Job. As you can see, the fine-tuning job creation is in progress. This job takes around 40 minutes to 1 hour to create a custom model. So let's wait while the process completes. Now that our fine-tuned model is ready, so click View Custom Model Details. You will see the same options we choose earlier. Feel free to spend a little time exploring them. Next, let's move on setting up inference. Keep in mind that this step will incur charges. If you would like to avoid that, you can simply follow along with the video without actually doing the hands-on. To run prompts on the custom model, we need to create an inference. Inference is just the process of using an AI model to generate outputs. On the top right corner, you will see the option Set up Inference. Click on that and you will find two choices: Deploy for on-demand and Purchase provisioned throughput. Think of deploy for on-demand as a serverless access. You don't pre-reserve capacity. The model runs when you call it and you pay per request. It's best for experimentation, small workloads, or unpredictable traffic. Next, purchase provision throughput. Here, you reserve dedicated capacity for your model. You pay for that reserved throughput whether you use it or not. Best for production use cases, high traffic applications, or latency sensitive workloads. For our demo, deploy for on-demand is the better choice. The steps are pretty simple. Just give it a name, something like on-demand inference. The model is already selected and the description and tags are optional. So just click create. It usually takes 20 minutes to set up. So let's wait while it finishes creating. Our inference setup is complete. Now select the deployment and click test in playground. This is where we can try out prompts. Switch to chat mode. Click select model. Scroll down and choose custom model. Then select MIG25 model and click apply. To run a prompt, go to the dataset, copy the user question, paste it as your prompt. You might notice that it doesn't always return the exact answers from the dataset, and that's normal behavior as a part of fine-tuning limitations. Fine-tuning doesn't always make the model memorize every single example perfectly, especially if the dataset is small or if the model's base knowledge is very strong. As a result, the response may sometimes be more general, or the model might not recall exact internal details. The key takeaway is that the fine-tuning model has learned the patterns and style of the dataset, even if it doesn't return the exact response every time. In real-time setup, you would typically test with hundreds or even thousands of examples or use addition techniques to improve recall. And also, S3 generated some validation results which can be used to verify how well the fine-tuned model is performing, check for errors, and ensure the outputs match the expected patterns from the dataset. Now, as a part of cleanup, delete the deployment. So go to the custom model. Scroll down to the deployment section. Select the deployment and click delete and confirm the deletion. Now delete the custom model. In the left navigation, under Tune, click on Custom Model. Select the model, go to Actions, and click Delete. Type delete and confirm the same. Now go to S3 console, delete all the objects in the bucket by providing necessary prompt and click Delete Objects. Now delete the bucket by specifying the bucket name and click Delete. Now go to IAM console, select the role used for the setup and confirm the deletion by providing the role name. That's it for today. If you have any questions, feel free to drop them in the comments below. Thank you for watching and I'll see you in the next video. Take care and happy learning.